Hey guys, today we're going to be looking at lesson 4.2 and 4.3, and this is part 1 of those sections, and we're going to be looking at postulates and theorems for triangle congruency. So before, when we're talking about congruent figures, we need all angles and all sides to be congruent in order for us to prove triangle congruency. Today, we're going to talk about 4 shortcuts. And these shortcuts, we only need 3 pieces of information. We only need 3 sides / angles. So before, with a triangle, we would need all 6 pieces of information, the 3 sides and the 3 angles, in order to prove congruency. But now we're going to be looking at some shortcuts. Our first shortcut is called side-side-side congruency. A lot of times you'll see SSS. And here this theorem states, if 3 sides of a triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. So here it states we only need the sides, all 3 sides of our triangles, to be congruent. We don't need the angles. So our shortcut here is side, side, side. And here I have 1 pair of sides. I have a second pair of sides and a third pair of sides. So with that, we are able to write our congruency statement. And we want to be careful as we write these. The order of the first statement can be whatever order we would like. I'm just going to choose A, B, C. Keep it alphabetical order there. The order of the second triangle, it must match the first. So for example, A is between the sides of 1 tick mark and 2 tick marks. So the corresponding angle there would be D. It is also between the 1 tick mark and 2 tick mark sides. So we know D and A, they're going to go together. E is the angle that matches up to B. F will be the angle that matches up to C. So when writing your congruent statements, be careful of the order, especially of the second statement. Now, we could switch these around. Let's say we chose to do CAB for our first. Then the order of our second one would also switch around. We would have FDE. So both of these statements are the same statement, however, the order is just switched around a little bit. Okay? All right, moving to our next shortcut. We have what we call side angle side. And side angle side, it says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. So here we have, looking at our picture, we have our first pair of sides, our second pair of sides, and then we have what we call the included angle. That included angle is going to be sandwiched. It's going to be between those 2 sides. So here we do have enough information for our shortcut, so we can write our congruent statement. And our first triangle, the one on the left, I'm going to write it as DOG, triangle dog. And then we want to match up the corresponding parts. So D is between the side of 2 tick marks and the blank side. And that will match up with A. A is also between the 2 and the blank. So we have triangle A. O is between the 1 and blank, which would be T. And then G and C will be corresponding. So here we have triangle DOG is congruent to triangle ATC. All right, our next two shortcuts. Our first is angle side angle congruency. And it says if 2 angles and the included side, so now we're looking at included side instead of angle. If 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the 2 triangles are congruent. So here we have E and O, that's our first pair of angles. We have B and S, our second pair of angles. And then we also have this side that is sandwiched between those two, meaning included, of the 2 angles. So as we write our congruent statement for the triangle on the left, I'm going to start the order out as BEN. And B is the angle that has 2 tick marks. S is the angle that also has 2 tick marks. So we know that the second statement is going to start with S. And then E and O are corresponding. And then N and N are corresponding. So here our congruent statement is triangle BEN is congruent to triangle SON. And our final theorem for today, we have angle side. And this states if 2 angles and the non-included side. So we've been working with included, now we're talking about the non-included side. So 2 angles and the non-included side of one triangle are congruent to 2 angles and the non-included side of another, then the 2 triangles are congruent. So here we have K and D as our first pair of angles. We have E and R as our second pair of angles. And then here, our side that matches up, they are non-included, meaning they are not between the 2 angles. So here we could write our congruent statement starting out with KEN and K and D, they will match up. E and R and N and A. So triangle KEN is congruent to triangle DRA. So those are our 4 shortcuts to triangle congruency. So on our next slide, we're going to just look at some examples here and practice which method we can use. So our list to choose from would be side, 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 angle, side, angle, side, angle, and angle, angle, side. Now, some common examples that we will come across may be angle, 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 and SSA. These are 2 that we cannot use. So they look very similar to the 4 that we covered in class, but we cannot use either one of those shortcuts per se. So I want to start out with our first example here. We have 2 triangles. We have a pair of sides. We have a second pair of sides. And then an angle that is congruent, and that angle is included. So we could write this as side, angle, side, which is on our list to use. So check. Those 2 triangles are congruent by side, angle, side. Our next example, we have our first pair of sides. They both have 1 tick mark. We have a second pair of sides. And we have a third pair of sides. So we have all sides here. So this is side, 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 which we are able to use from our list. For our next example, we have, we'll start with the angles here, a pair of angles. We have a second pair of angles and a pair of sides. So if we write our shortcut, we have angle, angle, side. That side is not included. It's not in the area between the 2. For our second triangle, we have angle, angle, side as well. Now, normally we could use this. However, I want you to look at the information. Notice where the side is located, what I have marked in green. The non-included side here is next to the yellow angle. The non-included side in the second example is next to the orange angle. So those non-included sides, they are in different positions. So because they are in different positions, we are unable to use angle, angle, side at this time. All right, so we would simply put as our answer, not enough info. Not enough info here. Moving to our fourth example. As we're looking at our angles, we have a pair of angles here. We have a pair of sides. And we also have a pair of angles, 2 pairs of angles, and a pair of sides. Now, as we write down the shortcut for each triangle, for the left triangle, we have angle, side, angle. That side is included. For the triangle on the right, we have angle, angle, side. That side is not included. So because we have a mismatch, here, we are unable to use any shortcuts. So our answer again will be not enough info. Moving to our fifth example. So as we match up the information that we have a pair of angles, we have a pair of sides, and a second pair of sides. So here we have side, side, angle, side, side, angle. Let's try to write side, side, angle versus angle, side, side. We want to use appropriate terms when we're in math class. And this shortcut is on our list of we cannot use it. So here, not enough info. Not enough information. Our final example, we have a pair of sides, we have a pair of angles, and we have a second pair of sides. So as I write the shortcut for each example, the one on the left, we have side, angle, side, with the included angle there, as well as for the second one, we also have side, angle, side. So here, check. These two are congruent through side, angle, side. Now there may be some other names that we come across, and these are particular to right triangles. So with right triangles, we have what we call, the sides can be called legs, and the long side of a right triangle is called the hypotenuse. And we will discuss some of these later. But in a right triangle, if you come across side, angle, side, sometimes you will see the letters LL mentioned. So LL is equivalent to side, angle, side in a right triangle. That LL stands for leg, leg. Okay. When we use angle, side, angle in a right triangle, you will see leg, angle being used at times. And then we always have that one exception in math, which we'll discuss this in our next chapter, which is the second half of chapter 4. This only applies to a right triangle. When you have SSA, you can use that only in a right triangle, but we call that HL. Okay, so SSA is only used in a right triangle, and we call that HL. All right, to close our lesson, you may come across some examples that appear to have not enough information, but we can use some concepts from chapter 1 and even math 1 to help us find extra information. For example, in example 1, as we go through our checklist, we have a pair of sides and a second pair of sides. Well, right now, that is only SS. And remember, we need 3 things. However, in this picture, we have an angle that we can label as congruent. We actually have vertical angles here. I call this the hourglass shape, which you'll see it a lot of times. And when you have that hourglass shape, we are able to use vertical angles and add that information in there. We can add our tick marks in some cases. So now that gives us side, angle, side, which proves that those 2 triangles are congruent. with example 2, we start out, we have a pair of angles. We have a second pair of angles as well. So we have angle, angle, which at the moment is not enough information. It's only 2 pieces. However, there is a side that goes between the 2 triangles that they share. And we can add a tick mark here because those 2 sides are known as reflexive. So we can add a tick mark to a side when the 2 triangles or the 2 figures share that particular side. So that gives us a side as well, and that's non-included. So we have angle, angle, side, which we can use to prove triangles are congruent. So at times it may seem like there's not enough information, but if the triangles are connected in somehow, whether they are this hourglass shape or this, I call them stacked. If you see the hourglass or the stacked, know that you can add vertical angles or the reflexive property in there to help find additional information. All right, that wraps up lesson 4.2 and 4.3. Complete the assignment, complete your homework practice. And if you have any questions, please get in touch with me.